could only drag it when it was unsnapped. So let me talk about what I'm doing lately. This may or may not be a very edifying stream to watch because I'm not going to be adding any new features. I'm going to be trying to simplify what I already have. So if anybody watched the previous stream that I did, it was a demo of polymorphism kind of features, or templates or parameterized types, or there's a lot of ways of saying this kind of thing. But it's a cool feature that's very useful. However, in building it, things had to get a lot more complicated, and the complications, internally to make that functionality work, seemed to reach a point that felt kind of unsustainable to me, or it was sustainable, but it would make a very high friction environment for me to continue with compiler work. And so every time something like that happens, I go and I try to re-architect the core of what's there until it still works but is much simpler. And that's facilitated by the fact that now I have probably 10,000 lines worth of test programs that I can run, and I can make sure all the test programs still work and all that, and I can track regressions and whatever. So let me try and talk about what got really complicated, and this may be a little bit esoteric, I guess, unless you've built compilers or you know about compilers, but I'm going to try and communicate all this, and we'll see. Someone's asking about games, but I'm talking about compilers right now. Anyway, so usually when you parse a program, like say you parse a block of statements in a function, usually that will at an early stage of the compiler get parsed into a tree, and what that tree represents is a bunch of little swappable pieces that represent expressions, where an expression is a very common thing in your language, and they're linked together in a certain way that the compiler knows how to navigate, right? So if I had something like let's say I had a statement, text color, Photoshop. I had some statement like if, let's not be italic, regular. So I have some statement like if x is equal to 3, printf hello, right? Then that actually gets parsed into something that's actually a little bit involved, right? Can I draw on this? Yes. So you'll get something. You'll get a little node here that represents the if statement. This is going to be very, very messy, right? And you're going to have links between that and other things. So I'm going to label these in a second so it's more clear, but this is like the if, and this will be like the equals, right? And you're asking if x, wow, this is going to be beautiful, x is equal to 3. I don't have a tablet that I use commonly, so my drawings will not look nicely like Casey's do. And then, so that's the if side, and then the then side is an array actually of statements, but there's only one. I'm going to draw two because like whatever, but in this case there's only one, and it points to a function call that has an argument list. And in this case, again, there's only one argument, but I'm going to draw multiple ones. And one of those arguments, one of those arguments is the expression hello. All right, so now I'm going to label that. Where's the text tool? We'll go down to 50. So this is the, no. I don't know why Photoshop's text color is so unpredictable and weird. So that's the if. That's not. Let's go to bold. and 75. Okay, so this is the if, not the if, right? And what's the shortcut for text tool? T? Yeah. And the shortcut for this is, there isn't one? I don't know. V? T, V, okay, T. That's equals, oops. Equals x 3. This is going to be terrible, but this is a block of statements. This is a function call. Oh, I forgot something, right? That's a constant expression. Hello. The thing that I forgot is the expression of what the function is, which in this case is a simple expression of just printf, right? So what happens is we take this statement and we digest it into something that's very tree-like, like this. And then when we're checking the syntax and we're checking the types of things, the compiler needs to navigate this tree, right? So if we want to know what printf is and if that's a valid function that we can call, then we go walk down the tree to the right place and whatever. And there's different phases of compilation, right? So the first phase is parsing, and parsing is what takes the text and generates this tree. And then we have type checking and type inference, which runs after that, which checks this tree and makes sure everything makes sense. And then if everything makes sense, then you go on to the code generation phase, right? And you may manipulate this tree somewhat during the type checking phase. Okay, so this is what I've said so far is basically very common. This is how most compilers work. Very, very common. Now, there's a problem here. Now let me sort of describe the specific problem for my language, and also for some other languages that work similarly. The main constraint being that, hey, the language isn't allowed to have header files, so things aren't necessarily pre-declared. So you'll end up parsing some code, right, like this code here. I might parse this before I've ever encountered a definition of X, or before I've ever encountered a definition of printf. And the compiler needs to be able to do the right thing with this and get through both the parsing and the type checking phase, right? And be able to give it to the code generator. Now, in a very simple statement like this, it's maybe not very hard to manage. And in fact, the earliest version of my compiler did this fine, where when you would parse this, you'd put it in this tree, but you'd say, hey, there's some identifiers that we don't know what they are. This X, we don't know what it is yet. And this printf, we don't know what it is. So we're going to put some tags on this tree where we don't push this tree through the type checker until definitions for X and for printf have come in, right? And if they never come in, then we report undeclared identifiers. But once they've come in because a different file gets loaded, or maybe they were there already, then we can compile this, right? And the reason you have to wait is you can't type check x equals 3 unless you know what type x is, right? X might be a string, in which case you should give an error, but you can't, right? If you don't know that. So that's all fine. For something this simple, that scheme that I just described works. It starts to get more complicated. Let me start pulling up some actual code examples that you may have seen if you watch the live streams. It starts to get more complicated in real situations. Well, let me go to the one that I'm trying to make work today. So, functions don't just tend to have one thing, they tend to have a lot of things in them. So they'll have like a lot of identifiers that they're referring to, which isn't necessarily that bad. But they might define local symbols, right, that you refer to with identifiers down here. Um, something might be a local symbol. It might be a parameter of a function. Let me find something with function parameters. I guess most of these were. So, here's a function and it's got a parameter and stuff. Now, in order for this scheme to work, like I was talking about, where there are tags saying these identifiers are undeclared, wait for it, then this whole thing that we're talking about here sort of needs to be in a little bit of a separate compilation unit, right? So this guy lives in a box. I'm going to actually try and make a somewhat better box. So this guy actually lives in a box somewhere, right? And then you've got other functions living in boxes. Like maybe this one is actually printf, and we're not going to look into it. We're just going to say, okay, that's printf, and then you might have something unrelated to anything you're doing, like over here. Whoops, over here is some function foo and whatever, right? So you end up having a bunch of these boxes that can get compiled separately. So this one you might say at some point, okay, this is waiting on x and printf, right? But then x comes in later, right? Or printf comes in. This guy over here gets through the type checking phase, and then we know what type printf is, right? And so that means we can cross it off this list here of what we're waiting for, right? So now we're not waiting for printf anymore, we're just waiting for x, and at some point when x comes through, then we can compile this guy, right? So this whole tree gets this dependency that says, waiting for type of printf, right? And then something else is going off somewhere else saying waiting for type of x. And there are other things you could wait on besides the type, but we're going to keep it simple because type is the problem I'm going to deal with today. So now this has been the architecture for a long time. And it mostly works. You can do quite complicated things with this. But as features started to get more and more involved, this architecture started getting more messy. So for example, if we go to what was it called? What was the one called with the arguments? Did I never check that in? Is it just called arguments? I guess so. Okay, so here's the demo that I did with default arguments and named arguments, right? And so default arguments, you can say something equals something on the right-hand side. And what starts to get complicated is this can be a symbol, right? Like printf or something. In fact, I think I have an example. No, that's in the right, so here I have an argument with a default that's, a function somewhere, right? So now you start to get this complicated structure where we're trying to determine the type of this, but we don't know the type of this. And where does that live? Well, for various implementation detail reasons, it lives on the declaration. So this is a declaration, and that's a declaration, and that's a declaration, right? A declaration is binding a name to a value. And it turned out, early on, the only declarations that were sort of flying around the system trying to find other declarations to hook up with were the global ones. You know, like anytime you define something at top level, that would sort of be an asynchronous thing that could complete at any time independently of anybody else, and the compiler would wait to make that happen. But then various other things needed to happen. So like a struct or a local function inside a function needs to be treated just like a top level, or a struct. If you force a struct to wait on all its members to complete, then you could very easily get a deadlock where a struct is waiting for something else, and that struct is waiting for something else, and that's waiting for your first struct. And the compiler should be able to handle it, but it doesn't because they're all blocked on each other. So for that reason, each of these declarations spins off independently, right? And then this declaration waits, and when all his members are completed, then he completes, right? And you start getting more and more cases. So you know, when you could pass default arguments, that could be symbols somewhere. Now this declaration had to fire asynchronously, whereas before, this function used to own these declarations. Like this function owns its whole body. So this is a declaration, but he doesn't fire asynchronously in one of these big boxes. He just waits and gets resolved when we do this, because once we've got the header of this, then we can start going down this procedure in order and resolving everything, right? But the problem is getting all this right started to get hard. And then once we started adding, once we started adding polymorphic stuff, let me go to a complicated case. So here, okay, this is a declaration. And now we start parsing a declaration. And it's got another declaration. And so since the rule becomes all function declarations have to kick off their own asynchronous thing, first of all, we're kicking off a lot of declarations that are trying to get resolved. But secondly, now we have to start doing complicated things where we undo them, because a polymorphic function doesn't actually want to get compiled because you don't know what the type is. But here we don't know that until after we've already queued a declaration for asynchronous processing, right? Then we're doing a second declaration that's got it. Oh, and it's also got this. That's a declaration. Even though it doesn't have a name on it, it's still a declaration, just like if you said int, right? And so by the time we get to this $t, we've done a bunch of work that then we need to roll back, right? Because this whole guy, either we need to roll it back or we need to like wait and then re-recurse the tree later and do all the declarations. And that started to get complicated, and it started to be a whole lot of other if statements. But the other thing that happened was I was trying to do some font stuff. I actually won't go look at the source, but it turns out there's a very old problem that I forgot, which is there's a very simple construct that this architecture won't handle, which is just if you've got some struct that's, you know, say you've got A, which is a pointer to something, right, some structure, right, and then you want to say A.B.C, right. There are some cases in which this architecture can't handle this very simple expression, right? And the reason is, I'm sure I've lost like 99% of people, but let me try and explain what's happening, right? So like I said, you know, blocks of functions can have a lot of stuff in them. So let's say I'm compiling this function, right? The old model of this compiler was I get everything ready. Well, so this function's called modify, right? So whoever this guy depends on that lives in here, like struct type info or this function new line or printf, basically all those get recorded as undeclared identifiers, right, in this table. And then this function modify is waiting on all those guys. And then the theory was when all those guys complete, then we can compile waiting on in one big unit. And I'll explain why that seemed to be necessary in a minute. But the idea was once you start compiling this, you can't actually stop until it's done. And by compiling, I mean, you know, type checking and inferring. Like you could parse it, but once you start trying to assign meaning to things, you can't stop until it's done. And so the whole structure was set up to enable that. And the problem is, if you say x equals a.b.c, and a is something that's only determined locally in the function. So let me bring this in. Oh, I don't have my, someone made a mode for this language, but I haven't put it on this this Emacs yet. Oops, I'll do that next time. Anyway, so say I had my function modify, right? If this if this is a struct that has some other structs in it, like b is external struct, right? So I don't know what external struct is because that's defined somewhere else in the program. Actually, in this particular case, you would be able to know. No, you can't. Right. Okay. So here's the thing. You would think that ahead of time you know what a.b.c is, because you know that a is a struct and you know that b is something external struct, and so you can wait on external struct. You see, you get like modify waiting on type of external struct, right? So when external struct comes in, I could compile modify. But the problem is I don't know what C is, right? C is some member of external struct, but I have to, in order to know what type C is, the mission statement is I need to wait on the type of C to compile, otherwise I will not be able to type check X, right? So there's this variable X, and C needs to be defined before this statement makes sense, right? So what's C? Well, it's some field of this. Now, I can wait on this, but I can't know that I'm waiting on a subfield of this unless I put this line and this line together, which is exactly what the type inference step is supposed to be doing, right? So I could either have this whole other redundant system that scans my program for these kind of cases and does these dependencies, or I can refactor it to work a totally different way. This has been a half-hour-long explanation, but I'm trying to lay the groundwork here for what I'm doing. So in the end, rather than doing some ugly hack that makes things more complicated, I came up with a way of simplifying the systems that I could get rid of some of these subsystems of dependencies. And because when I was trying to build new features, especially in the last few days before that polymorphism demo, 90% of my programming time was not really implementing features. It was dealing with problems that came up in just to deal with the fact that the language doesn't have header files, right? Problems that came up about being confused about when things are ready to be compiled and whatever. So that the system like sorely needed to be simplified. And if it doesn't seem that complicated here, just keep in mind I've only explained the basics without all the special cases and all the different types in the language and what they particularly need in each individual case. So now, in order to explain to you what the simplification is, I need to explain one last thing, which is why I said that we need to have all the dependencies satisfied before we try to compile this, right? Now keep in mind, as always, that things can be a lot more complicated than I've pictured here, right? So, you know, my function is not necessarily going to be just this. It's going to have a lot more stuff pointing in a lot more places, right? Like a real function that does real work is just gnarly. It's like a big tree with a lot of things, right? And a lot of depth to it. Whatever. It's just going to get messier and messier. So the way that we typically do this in a compiler is we start out, and anyone who's done some basic computer science will recognize what I'm going to say here, right? It's just you start out at the root of the tree, and you have some function that handles everything. So a thing that handles if just knows, oh, well, if is a statement, so its return type is void, but I've got to check the conditional. So let's recurse and check the conditional, right? And then, let's pretend this expression is more, let's say this is f of x and not x, right? I shouldn't have written that in the same Should have written that in the same color. Anyway, pretend this is more complicated than x. So now I'm type checking equals, and I know, okay, equals is something that returns Boolean. So this is going to be type bool here. Let me switch to a smaller font. This is going to be type bool. But we need to check that these types here match each other. So now we need to go evaluate this, right? Which means we need to evaluate this, etc. So by the time we get down here and we're type checking things, we're actually in a deep stack. We're 5 deep in stack of my C++ program, right? And that stack might look like type check if followed by type check binary operator followed by type check I don't know, type check function call. This is not the actual names of my routines or whatever. And we might get down to type check identifier, right? So this is not actually 5 deep. Right? Type check declaration. So something like that. This would be an extremely simple stack, actually. Let me give that a little woohoo. Da, 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 da. This is going to be too much. Will this not work? It doesn't do anything if it's not rasterized? All right. Rasterize. It still doesn't work. Why doesn't my outer glow work? Whatever. Okay, I tried to do it. Anyway. Photoshop. Oh. Not screen. Normal. There we go. That's excessive. That's excessive. The colors are terrible. I'm sorry. I'm sorry, people. Okay, whatever. Unreadable, but there you go. So, here's the problem. I call 5 deep into the stack, and I get down to type check identifier, and suppose I realize that I don't know what this identifier is because I'm doing this a.b.c and C is not ready yet. Like it hasn't been loaded yet, or maybe I've parsed it, but I haven't checked the types yet, so I don't know what type C is. I have to somehow stop this whole process of what I'm doing and resume it later. And there's many ways you could do it. One is you could complicate all the code of this recursive process to sort of re-recurse if types are already checked and redo all its stuff. That was one option. I didn't like that. Another option is what the guy doing the crazy new decompiler did, which is like all this type checking stuff like runs in a fiber, and so when you come down here and something's not ready, you like suspend your fiber and you're going to resume it later. But I think fibers are way too complicated, and I think that they're also very bad for performance because, well, you can't really do things data oriented if you're doing fibers like this, because it's like being object oriented, where you're treating one thing at a time and you're doing a bunch of code for that thing, as opposed to taking everybody who's in a certain phase of compilation and running them all through the tables and stuff, which is much friendlier for data structures. So I'm doing a third thing, which is I'm converting this recursive process to an iterative process. So what I do now is I do a pre-walk where instead of doing real work the first time I walk this tree, these purple arrow, God, I'm still, maybe I'll do this just to emphasize. Okay, so instead of now actually doing work in this initial pre-walk, I build an array, and what this array is, oops, that's terrible. I build an array, and what this array is pointers to all the nodes, right? So let me start using a different color before we totally can't read this anymore. Let's go orange. I'm trying to stay at least. So these are pointer to here, right? Pointer to here, pointer to here. So they're pointers to these things in the order in which they need to be processed. But because we don't have to do any work, or we're not trying to do any work while we build this array, we never need to suspend this and resume later. So dot, dot, dot. So that all happens. And then my process of type checking and resolving identifiers both happens by linearly iterating over this array. So if we get to this, I guess I left out my unresolved identifier. Let's, oh no, I didn't use enough layers. So, that there is the place where we had our problem where we had to resume. So when we get here and we say, oh, not ready, right? Not ready, then what happens? Well, it's very easy for us to pause this and resume it later because we don't have to use a fiber. We don't have to use some really deep, horrible long jump or anything. We just have an index to where we are in this array, and we put this guy aside, and we say which identifier we're waiting for. And when that particular identifier is ready, then we can come back. But what's great about this is it simplifies all this structure. You don't need this whole outer structure out here of waiting on all these guys anymore. Right? Like you can get rid of that, and you can get rid of that, which actually, I've only drawn this as two arrows here, but it's actually quite complicated. And you can get rid of this, really. And you can get rid of all those special cases I talked about, where, like the reason when I said before that your function parameters had to go, like, why these declarations had to go fire as separate units, is because of this kind of guarantee that you had to have of your type checking phase being atomic, right? If your type checking phase doesn't have to be atomic anymore, then you can fold all this stuff back into this block, which will make the compiler more efficient, right? Because it's not doing as many crazy cross-references. It'll make the code simpler. It'll get rid of all these special cases about, like with this steal thing about, oh, we've issued some of these guys to go fly and search for dependencies, but then we have to unissue them later. Like, it'll just get rid of like whole swaths of the code. Okay, so that is what I'm doing. And now that I've explained that for like 45 minutes, I'm actually going to get some water and make some tea. And I'll take some questions about that because I'm sure almost nobody has any idea what I'm talking about. But I'll take that break, and then I'll come back and actually start completing the work, keep working on the actual work that is making this happen. And that'll be fun because I have a problem and I just haven't thought it through yet. So that'll be amusing. So 4 to 5 minute break, and I'll be back. Well, I'm back or something. So do we have questions? Couldn't I do this in multiple passes? Is the reason you don't performance, or am I misunderstanding something about the problem? Well, the multiple passes does sort of happen, but like I was saying, the problem is stopping in the middle of a pass, right? Like there already are multiple passes in the compiler, but this type checking thing I was talking about is one pass. So if you want to stop in the middle of that pass, you have to do something complicated to enable that, stopping and resuming, right? And the reason I like this linearization thing, I have surprises, like if it works out well, I have surprises later on that relate to this. But in general, it's always been my experience that when you can disentangle the control flow of your program from the structure of your data, it's always a win. Which, like Lisp people or whatever, would say, no, that's not true. It's powerful, but I don't think it's powerful, because when your control flow is not slaved to the structure of your data, it means you can reason about the data. You can see the data from the outside. You can see what's happening with the data, and you can make choices about how to treat it, right? Whereas if you're forced to recurse and like handle these things with different functions, and your call stack is bound to how deep in the data you are, you can't really see what's happening from the outside. You can only see it from the inside as the program. And all my experience as a programmer leads me to believe that that is, in the long run, a less powerful thing. It's a less powerful vantage point to have as an algorithm operating on data. So when you've got all this stuff linearized, it's just you see this whole array from above, and you can just iterate over it, looking for things that you're interested in, right? And pulling them out and operating on them, which is why I wanted to do it this way. Someone's asking, did I find the ghost? I don't get it. In C++, the expression A, B of C can be more than one thing. Hold on. Variable declaration or function declaration only gets worse with templates. This affects the generation of the AST itself. Do I have any similar problem? I don't have any similar problem yet, and I hopefully never will. So I can generate the syntax tree without knowing the type of anything. And that's a thing that's true for a lot of languages, actually. C has that problem because of the way typedef works. And it's widely regarded as a bad move that C made. So in this language, types are just symbols the way anything else is. So you parse them as an expression. So, well, as an expression, or a type expression. So one of those two things is always the context in which you're reading a type. So it doesn't matter if you see an identifier there, you sort of know what it is. It doesn't matter. Not sure I understand why the C would be unknown when you start to type check. Somewhere in the program there would be a definition for the C, and that would be passed before we try to type check anything that uses C. Right? No, not right. That's the entire question, is how do I know what C is? Because for modify to wait on C, I need to know what C is without computing the type of B, right? If I compute the type of B, then I can know what the type of C is. But computing the type of B is the whole point of type checking modify. So if you're saying I have to type check modify before I can type check modify, that's kind of messed up, right? And I could do some ugly hacks to get around that. But if I'm looking for the very clean, very simple solution, then I'm going to try and re-architect it so I don't have to type check modify before I type check modify. You get what I'm saying? Oh, you said there was a ghost in the office. There is someone besides me in the office right now. This is an actual office where more than one person works, and sometimes have recreational times playing on the PlayStation 4. So that's all good. All right. So, with all that explanation down, um, so where I'm at in building this whole system is that all this legacy stuff of these individual units pointing to other individual units is still active. The goal is to get rid of all that stuff, or at least for the purpose of looking up identifiers. There will still be this kind of big blue box pointing at other boxes for other reasons. For example, in the polymorphism chapter that I demoed, you had these modify functions that could modify the types of arguments to template functions, right? And if you're going to therefore even type check a function call to a template function, you need to have fully compiled the modify function, right? So there's still going to be dependencies that point at each other. There just won't be nearly as many because you don't have dependencies for identifiers, right? And so for things like identifiers and reaching outside of your current function, the idea is we just always start compiling you till we hit a roadblock. And when we hit that roadblock, we wait until later, and then we just try you again later. And because we don't have this deep recursion, then this is much easier and more lightweight of a process, and we don't need to take on onerous structural issues like fibers or whatever. So where I am is that recently during my like yesterday evening, I sort of got this flattening ostensibly working, where the code at least runs well enough that it does this flattening and goes past it. And then I realized actually that this is a little bit of an oversimplification because I don't actually want the pointers to these individual nodes. I want to store the pointers to the pointers of these nodes. So instead of pointing at here, let me get a little darker. Instead of pointing at here, for example, this arrow would point at the start of this arrow. And instead of pointing here, this would point at whatever points to the root of the if. And the reason is that sometimes you need to be able to swap an expression out for another expression. There's two major times when that happens. One is when you're evaluating constants. So if x is some constant and I resolve a definition for x, then instead of keeping x in here, I swap it in. So if x was 5, I actually replace x by 5, right? And the reason that we do that is, imagine that this was not as simple as x, but it was like x pointing to y, y pointing to z, right? And all these things are constants. At some point, you've got to collapse that, or you don't want to be dealing with arbitrarily going down this long sequence of things to see if something's constant. And right now, the time at which I do that is in type checking. I suppose I could do it in bytecode generation, but frankly, I'm not sure if there's an advantage to doing that. Like code generation or type checking seems to be like a good place to do that. However, the naive version of doing that would be, okay, so the other thing to make clear is I still have all these functions here, like to type check for each type of node that's in my program, because you still need to do something where you say, oh, equals is a returns bool, and let's check the arguments against each other. You just don't do it recursively underneath another call. Now you just do it. This array down here calls these things now. So the thing is, every single one of these functions naively would have had to check for const substitution on anybody that they point to. That's very annoying. If I were using some better programming language, like say the language I'm working on, then you could at least auto-generate that code by enumerating all the types in your program and checking to see if they have pointers to other kinds of, abstract syntax tree nodes, and if so, generate some boilerplate. But you can't do that in C++ without adding a great deal of messy tools level external to your program kinds of things, which I am not willing to do. So instead, what I'm doing is I'm storing the pointer to this node, right? And that allows me to change this if I need. Well, let's say I'm storing the pointer to the head of this. So if we decide that x is really 5, then I actually cut this, right, and I redirect it to the 5. So that, to a first approximation, appears to work now for const substitution. But now when I run the program, I'm getting type errors in demos that used to work, and I'll show you why. So here's, I'm getting an error at line 568 of this demo. And this is a time, where I'm calling this function print entity AOS, which wants a pointer to an AOS entity, and I'm calling it with a pointer to a regular entity. Now, if you've watched the previous demos enough to know what AOS and SOA are, then you know that a pointer to an entity will or should automatically implicitly convert to a pointer. Oh, wait. Okay, no, sorry. This is a pointer to an SOA entity probably, because entity is defined to be SOA by default. So this is actually an SOA pointer. Wait. This is right. I just left it modified. I must have been demoing the error and left it modified. So maybe I don't have a problem, right? This is not supposed to work because this is an SOA pointer which doesn't trivially convert to AOS. So actually, I might not have a problem here. Let me just save that. All right. Now we have a legitimate problem that we can debug. Where I'm just dealing with fallout. Like anytime that I make a change this big, it just breaks a lot of stuff in the compiler, and then I have this job of like dealing with all the fallout, and that's where I'm in the middle of. So you may get to see me amusingly make little progress. But anyway, the point is to get this linearization thing working, and then once that works, then I can slowly start swapping out all the other identifier resolution and dependency resolving things, and then and keep all the test programs working, and slowly interpolate from the old system to the new system. And once all the new stuff is done, then I'll be able to handle more complicated cases and start building more real software in the language. So that's the goal. The goal is also to simplify the program as much as possible, which hopefully can be done by reducing line count. So right now we're at about 18,400 and something, which is about where I started. I was at about 18,460 when I started doing this cleanup, and we got down to about 18,200, and now we're back up. I'm hoping to get down to 17,000. Like, I'm hoping I can delete like 1,000 lines. That might be optimistic. We'll see. But even if it's less than 1,000 lines, the lines that hopefully will be deleted will be some of the most complicated things in the compiler that cause me the most friction, and that should enable a great deal of future progress. As long as we don't replace that by new friction by this new thing, which has already, I will say, turned out to be a little more complicated than I expected, which is always the case, but hopefully it doesn't get too much more complicated. So I guess I'm just going to start debugging and seeing. I haven't debugged on here in a while, so working directory is right. Test demo using SOA-HI. So I'm just going to do that and just see. Any questions now before I start talking some more or start doing actual work? This has been a long prelude to doing actual work, and I'm probably leaving at like 8:20 Pacific time. So someone asked before, could you build a tree of all identifiers first without type checking, then do another pass of the tree for making sure the types make sense? Not really, because that second step you're talking about is type checking. Like, that's what type checking is. And you can't make sure the types make sense without doing all your other type checking operations. So again, it reduces to the problem of how do I be able to suspend and resume type checking? Oh, I've got a bunch of old breakpoints here. Let me get rid of those. Okay, and my Visual Studio is, I'm not going to be able to see very much on the screen because Visual Studio is terrible. And we're not in an insanely high res right now. All right. look at all this wasted vertical screen space. Like, it's insane. Like, oh my God, it makes me so mad. Makes me so mad. That's why I will not be using Visual Studio in the new language, if I can help it. All right, so what happens is, I don't know. So where are we? We're emitting code, so that's good. That's emitting code is relatively late in the pipeline. It means this thing actually passed type checking, which is good. Let's see what it is. I put debugging information where I can tell what line number in file. Whoa. Okay, let me pop up a little bit. Sometimes when things are declared as temporaries that users are never intended to see, we don't set the file name. So let's look at the declaration. Okay, it's in the demo file as we expect, and line number 562. And it's using some type that's defined at line 248. So let's go look. Whoops. Let's go look at line 562. Well, it's right here where we were looking. So we're generating code for this. It's an entity. And it's using, line 248. Well, okay, so that's an internal sort of issue where what happened is the last file that it loaded was this one, and it's 248 lines long. So because I didn't explicitly set the location of this other thing to whatever created it, then what will happen is it just gets wherever the lexical analyzer says it is, which is the end of that file, which is very unhelpful. So I have another way that I can find out who that is, and then I can go in the compiler and fix that problem. But I'd rather sort of figure out a little bit about what's going on first. So here's another thing that's terrible about Visual Studio. It like says I'm on this line, but I'm really on this line back here, which luckily in this case it's not ambiguous. But like older versions of Visual Studio didn't have this problem. They would say, oh, you're in the middle of here. Now it's like, oh, whatever, you're down here. No, we're in here. We're calling this function on the inferred type of this declaration, right? So we're calling it. So here's the thing. This is a relatively complicated function because the implicit constructor, for example, is a thing that assigns all the default values. So in the demos, when I say, here's a vector 3 with default values of 1, 4, and 9, for example, then this is the thing that would set the 1, 4, and 9 when you create a vector 3. It needs to be able to do that on arrays, right? And it needs to be able to do that, or on vectors in arrays. You would call this on an individual vector, for example. But it needs to be able to do that on a vector for an SOA array or an AOS array, right? So the way that we know which it is that this SOA array index and SOA array size, they're -1 if we're doing regular old AOS packing. But if they're not -1, that means we're SOA. So the caller thinks, the caller skipped those arguments, right? Those are optional arguments. Right? The caller is giving the register that we're outputting the result into, and whether we're doing the constructor, right? If we're not doing the constructor, we're doing the destructor. So we're doing the constructor. It opted not to pass these, which means it doesn't think we're SOA. But sorry, the call's here. You can zoom this one window out in Visual Studio, so I'm going to do that. You can't zoom this other stuff as near as I can tell. But I'm going to do this just so I can see a little more code. I don't know how readable that is. Let me go full screen for a second. It's true. I mean, GDB is terrible. I wouldn't say Visual Studio is quite that bad yet, but Visual Studio it gets harder to use all the time. Oh my God. Okay, so So I need to figure out why we're in this whole path. And the problem here is this is, I haven't dealt with SOA stuff in a long time. And so will I remember it? I don't know. I'm going to turn on some lights to reduce eye strain here. So after like 2 years in this office, if it's been that long, has it been 2 years here? Damn, yeah. I still don't know which light switch does what. Oh, we got to ship this game soon. Um, anyway, yeah, I run the dark theme on my laptop, but whatever. I'm so fed up with like having to keep settings up everywhere that I don't bother anymore. Okay. So what the hell is going on is sort of my question. Like, so to emit the code for a declaration, so you figure out what the L value is because you need to store that. You need to store the result into the L value of the declaration. So we get a register from that thing that emitted that code. So that part worked. And then we do some special case things. It's not a dynamic or a static array. It is, let's see. It is an entity. Okay, here's what's going on. So an entity by itself, it's marked SOA but because entity is SOA by default, right? But there's supposed to be a pass that removes SOA from entities or from any type, right? If it's an implicit SOA on the outside of a thing, right? Because it doesn't, like, doing this doesn't make any sense. And in fact, if I say that, let me just say that explicitly so you can see what happens. Oh, it didn't matter. Maybe I checked that in the bytecode build after that assertion. But anyway, saying that something is an SOA entity like by value doesn't make any sense. The only thing that that would give you is an AOS entity, right? Because it's an array of one entity and like what, and you can implicitly cast from the AOS to the SOA. So you get a warning when you do this, like, oh, you shouldn't really do that because it doesn't mean anything. And so if there's an implicit SOA, we actually take that off. And so I think what's happened is this whole monkey business that I'm doing about linearizing this has caused that part where we substitute the new expression with the removed SOA, like that substitution is going into the wrong place or failing. That's my theory about what's happening. So I'm going to go into here, and I'm going to say, I'm going to try to, I'm typing random things to try and remember, because it's been so long, what I called it. Like, I believe that I flag things. Well, let me check. I know there's one like, oh right, I changed a lot of the names. Okay, so SOA default packing. If you say a struct is SOA by default, this gets to be non-zero. So now I believe in the parser, I check that at some point. So here is SOA gets set if we use the SOA keyword. So there I set the packing to 0. And I don't refer to it at all in this file, so it must be in the type inference, maybe. Wow, it's not there either. Maybe this got accidentally deleted at some point. But I don't think so, because that demo worked before I did this stuff. Maybe it's all in the bytecode. No? All right, so here we set this SOA packing. Okay, here it is. This is, okay, here we go. This is what I was looking for. There's this thing called the type instantiation, which is basically the type part of a declaration. And, that gets processed into an internally inferred representation. But the non-inferred thing has these flags about whether you explicitly put the SOA or the AOS keyword on it. And if you did either of those things, they get marked, right? So if you set both, this is what's checking all those. If you set both, you get this error. So let me just demo that to make sure it works. So if I do that, for example, yeah, it'll complain. And in fact, because it's SOA by default, no, right? This'll work. Well, then we get to some other error that I need to debug later. So that worked because it was overriding the previous SOA with an AOS, right? But anyway, so this generates that error message that we just saw. Now, if it's explicitly AOS, we set the packing to -1. Otherwise, this is, I think, what's supposed to do that stuff. And it looks like we substitute it correctly. I mean, this thing where we say star expression pointer equals front is where we substitute the pointer. Oh, okay. I bet you I know what's happening. I bet you I know what's happening. Okay, so this thing, let me go to the part that actually does this flattening. So there's this ensure flattened that, empties out every declaration has like that array of flattened expressions, which is this thing that I drew. And these functions empty it and call some recursive flatten thing and then do some post-processing. Now, as an optimization, there's duplicate checking in the flattening. So, if you don't want to recurse down into some subtree of your program twice, like if I point at a type twice, then you don't want to keep visiting it. However, you do, at least for now, I don't want to try and do that optimization because the problem is, if I don't actually know if this is the problem, but let's presume it is, if the same thing is pointed to by two different nodes, like let's just say there's a node down here and this guy points at it and this guy points at it, which could happen if it's the type of something, like let's speculate about where that might happen. Well, I don't know, like the left and right hand side of this same expression, right? The right hand side turns into some type and this turns into some variable declaration that points at that type. So you have two guys pointing at the same type. Now, this code that we just looked at wants to, this wants to make some new variant of that type and then swap it in for the old one. But if you didn't replace all instances of that pointer because you didn't, because you thought you were being smart and deduplicating them for recursion purposes, then you're going to fail to substitute it in all cases. So the thing is, we are going to end up recursing down here multiple times, I guess, and doing the type checking multiple times. But I guess we did that before too, which is not the worst news because for now we at least want it to work, and then we'll make it more optimal later. So the way we do that is we set this thing called polytarget copy up here. It's a confusing name. That's a pointer that was used for polymorphism, because for polymorphism you copy a function and then fill it in, and then compile, right? In this particular case, I'm just reusing that pointer because I didn't want to use more memory, so it's got a confusing name. I'm just going to neglect to set that. Oh, but I'll also neglect to check it. So down here is where I check it. And if you're flattening and you hit something you already flattened, then return. However, I believe now we have a problem where we do infinite recursion in some cases, and that's bad news. So I don't think I can actually do this. I think what I need to do is say, look, if you point at something from more than one place, because you can point at a thing that points at a sub-thing that points at itself eventually, and you don't want to infinitely loop. So I'm going to keep this bookkeeping, but I'm going to say if you hit that bookkeeping, then we're just going to add the top level pointer, right? We're going to add the top level pointer to our flattened result, but we're going to return. So we're not going to infinitely recurse, and hopefully maybe that's the right thing. We don't need to, yeah. I don't want to get into any more convoluted explanations. Let's see what happens. The same error. Well, possibly that wasn't the problem. It was certainly a problem, though. Ay, ay, ay. So let me verify that this is actually what happens. So here's another thing. So in the old days, when I wanted to set breakpoints about when certain things happen, I would make sure my code was deterministic, and then you could set data breakpoints based on the value of a pointer. You can't do that anymore because of ASLR, address space layout randomization, which is very sucky and anti-programmer. You can apparently debug it in some convoluted way on Windows, but I don't want to figure out how to do that on all my machines, especially every time I get a new machine every 3 months. So now I tag everything. So every thing that you can instantiate in a syntax tree has this just member called S, because that's easy to type. This is the serial number of where this guy was instantiated. So he's 4626. So provided that my program is deterministic, I can go to that place that I was looking at, right? And I can say, let's set a breakpoint here on the condition that the serial is equal to 4626, right? So we're going to do that. And apparently that wasn't the problem here because we never reached that code for 4626, which is itself probably a problem because I believe that we should have reached that code. Why is Visual Studio being annoying? Let me just try it up here. So this is type inference for type definitions generally. Where does 4626 enter there? Maybe, oh. Whoops. I did not mean to say single equals. Of course, my breakpoints window is closed because I'm not debugging. Breakpoints condition equals. That's something that I just recently said. I never make that mistake, but apparently I do sometimes, at least in the debugger. Now my window's not even repainting correctly. Visual Studio, you're terrible. All right, so it didn't even get to that. So here's what I say, is I go to the place where this is assigned. If I want to know, like, who the hell is this, period, I can set a condition here of allocation serial is equal to 4626. So now we will definitely break because somebody's allocating that guy. All right. So now we know, oh, it is make packing variant, right, which is what I thought. Oh, but it's the variant that's 4626. It is not the source declaration. So why is that causing a problem? What exactly was the error? Was it that okay. So for some reason, it's making a let me just return up. So here's where we are. It's front that's 4626, not this variable here. So we're making a variant that is of packing 0, which means SOA. And I don't understand that. I don't understand. While I'm here, by the way, this make packing variant is the thing that is not setting the location. So actually, hold on a second. I'm going to set a breakpoint here with the condition of front is equal to 4626, just so we can get back here very easily. I'm going to get rid of my other breakpoints for now. I'm going to go to make packing variant. There's just so much stuff in this menu now, it's like hard to find things. This is the thing, it's making a new thing, and it's failing to set the location info on it, which is why at the beginning of this debug session I didn't have the file or line information. But I should set that, I should copy that from the old thing. So I'm going to say copy location info from defen to result. So now, whoops, build, oh, is it, where the hell is copy location info? I just don't have the declaration here for some reason. It is a global. I guess I don't ever do it in this file. Well, God damn it. Paste. That is how I handle these things in C++. All right. Okay, so now we're back to, I don't know why my, oh, I didn't want front equals 40. I hope someone in the chat caught this. It's supposed to be front arrow S. Anyway, so because our breakpoint didn't work, we ran straight past to our original assert, but now if I try to ask the line number and file name, it actually tells me now, right? So I didn't have to pop up the stack and look. So we at least, if I don't finish anything else before I leave the stream, I at least explained to you what's going on and then made at least a minor convenience in the compiler. It's more than a minor convenience, it's a bug fix because there might be some conditions under which an error message tries to report the location of that type, and it would give you a very confusing location. Okay. So now that I've changed my error condition to be correct, so now we're breaking in the right place. Oh, hello from Worcester. Hello, sir. Who is saying, is this guy new to... Okay, you're getting banned. Sorry, bro. You're out of here. Don't annoy me when I look at the chat with stupid... Like, people come on and they think they can talk to you like as if you're a 13-year-old, 4chan user or something. It's like, what? Why is that even considered remotely appropriate? Anyway, okay. So I'm making a variant. Now what I don't understand is why I'm going from AOS to SOA. Why am I making a variant that's SOA? Because Why am I making a variant that's SOA? Maybe this is doing the right thing, but if so, I don't understand. So it's saying SOA packing should be 0, but the inferred type is -1. So this probably correctly had its SOA removed, right? Line 562. So that's probably this type on the right, and it probably has been post-processed to have its SOA removed. So why are we putting it back? Why did we decide to put it back? Well, let's just trace. So def in S is 1758. Let's start here. It gets set. It starts at -1, so it must be getting set to 0 somewhere, right? So let's condition def in S is equal to 1758. All right. Okay. See, if statements always make things complicated. Like I even have to think about what this one means. So you want as few as possible. So we're saying, okay, it's setting it to the default on the struct, which does not make sense in this case. I don't know why it's doing that. But it's doing it because, okay, we're looking up a type definition that's, its name is signified, or the type is being signified by an identifier. So you can see the name of this identifier is entity over here. I'll put it down here just so you can see it. That's entity. So that's no surprise. Now, what we're saying is use its default packing if you have a type and that type is a struct. Maybe that's right, and maybe it's supposed to get removed above this level. Although honestly, I don't really know where that would happen. This is where I get to be confused and not remember how. A good reason to simplify your compiler whenever possible is so that there's fewer chances to forget how things work months after you do them. I don't remember, like it's so complicated of a program that I don't remember a lot of things, honestly. I kind of program by intuition half the time. So, right, so the question is this part right? I'm willing to believe that this part is right and that we were supposed to swap it out at the declaration. Yes, okay, right. Okay, here, this thing that we're doing is anytime we're inferring types for a type definition. And type definitions could be anywhere. They could be like buried way deep, right? The place where the SOA is supposed to get stripped would be at the declaration level when you come up and you see like, oh, this isn't an array of SOA entity, right? Because if you did this, that SOA is legitimate. That means something, right? Here it doesn't mean anything. Or sorry, here it doesn't mean anything. And so the place where that stripping would happen is at the top level of a declaration's expression. Yes, and I bet that still happens. It's just it doesn't affect the expression pointer anymore. It probably only affects the flat array pointer. So what would stripping, this is totally how I debug. Like, I don't remember who does that. So what would it look like to strip the SOA? Well, we already said it's setting this SOA packing. So we would say SOA packing equals -1, All right, oh, it's this function, check for naked SOA, right? So check for naked SOA takes a type definition or a pointer to a type definition. If it's SOA and it's explicit, right? So if you explicitly mentioned it, it'll tell you, oh, that's not meaningful, and turn it back. Now, if it's not explicit, if it's something that just happened because, for example, your entity is SOA by default, then it won't warn. Then can warn is false when you get to this function, and it won't warn you. It'll just silently strip the SOA. Because it's not silently stripping the SOA successfully is why we're getting that error message, that assert later in the program. So, so who's calling this? Check. Probably is getting, okay, so this is the version that calls it with a declaration. If the declaration has a type, which this one does, we check for naked SOA. Now, if this happens, okay, so here's the confusion, is if this happens during flattening, or if this happens before flattening, it's fine, but it can't. This has to happen after flattening because you need to have resolved your types to know if you're supposed to check for naked SOA. And especially, like in this case, this declaration is internal to this function. So remember that flattening process that I was talking about? Flattened all this down into one array. So this declaration to an entity, or this type definition of an entity, is like one random pointer to a pointer in the middle of the array. And what's happening is this code was written before we had that concept. So it's swapping out this decl myType as if that would be enough, but it's not enough. Let me make sure that's the only calling site. Check for naked SOA. Yeah, so all these call the declaration version that takes 2 arguments, whereas this one takes more arguments. So I just have to fix this, and the question is, what do I do to fix this? It's a little bit annoying because I don't necessarily have a fast way to fix this. Because like I said, multiple people could potentially be pointing at this type, and I don't want to make like another data structure of everybody pointing at every type. So my feeling is what I'm going to do is I'm going to search upward for the flattened thing, and I'm going to wait. This ought to already work because I don't, like I said in this diagram, I don't store decl myType. I store the address of decl myType. Right? That was what this funky arrow pointing back to things. So in theory, I mean, I guess this isn't working, but in theory, I guess it should because I'm just changing the contents. Maybe it's like changing the inferred type pointer here. Okay, let me go back to, now that I've seen a little more of what's going wrong, let me run it all the way to the error. So I have a type definition. It's 4626, right, which means it's SOA. So what I can at least do is I can go to, actually, what declaration are we working on? That declaration's type is no, they don't matter. I don't know. Oh, decl inferred type. Oh, this is weird. commit code for implicit constructor. This type definite. Oh, sorry. I was looking at the wrong line. Looking at the wrong line. Okay, so this type definition is the inferred type of this declaration. So that just matches. I just wanted to check that this is the right declaration. So I can go into check for naked SOA. What was that number again? 1757, and I'll set a breakpoint there. I feel like I may not finish resolving this before it's time to go, but I'll be a little further. Decl s equals 1757. Let's build again. Let's run again. Okay, so here was where I set this up. So if my theory is right and the pointer swapping isn't working, then check for naked SOA should at least be doing the swap and just the result is failing to get to the right place. That's not even happening. That's not even happening. So why is check for naked SOA never getting called? That sounds very bad. Maybe I just deleted the proper call or commented it out sometime. Okay, if something is a lambda, I check its return types for naked SOA. That's not the condition we're looking at. I check its arguments for naked SOA. Here, post infer of a declaration, I check it for naked SOA. I don't call post infer anymore on declarations that are internal to functions because, well, let me check. Let me verify that that's true. Post infer is getting called by this wacky defer post infer call on infer types of a declaration, but this only gets called for top level declarations, which is probably really bad now, right? Because, okay, here's a subtle thing that probably happened, right? I have this function overloading of infer types. Let me show you all of that, right? I have several versions of infer types. Let me put them together for you. Well, I guess I just have two. I used to have one for a block, but I've deleted it. So infer types used to get called with this as top level, and then this used to be for, well, I guess this was always, like we would recurse down into everything below the declaration and do all this stuff. And let's go to the next infer types. So here's the block one that I got rid of. Okay, so this one checks what type we are and casts us to a bunch of different things and does some things based on what type we are, right? So what we're hitting now is this thing that used to do a lot of complicated stuff, but I've replaced it with some relatively simple code. And the problem is that that's not calling this other routine that does all this other complicated stuff. Now, we don't actually want to do all this complicated stuff anymore because, like, we don't want to flatten our things. We don't want to flatten our declarations that are inside functions because that would be stupid because they're already flattened on the outside. But we do want to do this kind of stuff. So, like, all this is like important type checking and things. So I think what has to happen, yeah, we wouldn't get default values. This is really bad. This was just an oversight when I was simplifying the code. So what I'm going to do is I'm going to add an if. So if is major, right? That's going to be a Boolean I'm setting. A major declaration is just something that flies around as its own independent unit, like I was saying. So bool is major equals declaration flags and declaration is major, right? So I only want to do this flattening if we're major. I don't know. There might be some other things that I only want to do if we're major, but probably not. It's probably only the new stuff, the flattening related things. If my theory is that this used to be called for everything. Yeah. All right. So the question is, whoops, this is in flatten, not what I was looking for. Question is, should I do this stuff and then call that function above? Or, geez, well. So that's what I'm saying, is that this never got called, and I guess I'll leave this. Maybe some of it's redundant and I'll clean it up later. Let's just see what happens. Let's see if we at least get a different error message. Yes, we do. We get a different error message. Let's just take a look at that. It's time for me to go soon, but I want to take a look at it and see what it is. So let's look at that in the debugger. This might actually be an error earlier in the program now, because we've changed. Whoops, I knew that. Oh, yeah. Okay, wait, this is just wrong. No, it's not. Line 13. It's a enum struct. Why does it not have an inferred type? Oh, because yay. All these if statements. Yeah, I don't know. It is a little questionable. By the way, if this looks messy with all this commented code and like comments saying this is disgusting or fix this and whatever, it's because I'm in the middle of ripping out a bunch of things, and that's just what happens. Like the whole idea is you go through a ballooning where you get messier and then you clean up, and then you get messier and then you clean up. And we're in the middle of a get messier phase. Well, the whole developing the whole lately set of features was part of the get messier phase, and now we're in a brief burst of getting a little messier before we can replace things with the new system and clean up. That's where we're at. So we've got this new problem where structs, let me make sure it's a struct and not something associated. Oh, it's the, right. It's the type associated with this enum, which is just going to be int because I didn't specify it. It gets something in its local namespace called strict. And if we look at decal mytype, we'll see that. No, we won't. Because we set the value. This might be a problem where dependencies aren't set up properly or something, because the expression is this type definition for strict, which is going to be, I'll cast that to, so we can take a look at that. Um, it is, an enum implementation with 3 members, but 0 are completed. So, we haven't parsed all the enum members and stuff. So we actually can't have inferred this yet, I don't think. Because I think it's supposed to wait until all the members are completed so that we know how big the number needs to be, right? Maybe that's not right. Maybe I always assume it fits in an int right now. But let me look at the declaration's dependencies. There aren't any. That seems a little bit wrong to me. Anyway, so this is a new problem that has been exposed by fixing the old problem. So the code doesn't work yet. I wasn't really expecting to get it working today. But that shows you at least a little bit of how the compiler goes. I guess I can do any questions that people have briefly before I finish up this session. Like all this stuff, these commented out lines are just like, this is what the code used to be here. Like recursively calling infer types. Guys who watch previous live streams may remember that kind of action. The whole point is I'm removing recursive calls to infer types by replacing them with the new system. So that is where we're at. Any questions? When do you get? Well, when it's ready. It's not ready. As you can see, I would like it to, first of all, at least be reasonably simplified and cleaned before giving it to people to hack around with. I mean, maybe people will just use the language, but I'd like it if they can monkey with the compiler as well. So I want that, but I also, some major features have to happen. Both in terms of the language design, some major features have to happen, but then in terms of implementation, we at least have to be outputting optimized code so that you can build real software with it. And then maybe I'll release it to a smaller circle of people. I gave an estimate of that recently of like 5 months or something. Who knows if that's accurate? It could be 10 years, etc. Yes, it'll be an open source project eventually. I'm just not open sourcing it yet because I don't want the vision of the language to be killed by design by committee early, essentially. I feel like if you have your own vision for what should happen, that's cool, and you can, play with it after it's kind of together. Or you can make your own thing now. But I want to get a coherent, the way that I design a game, for example, is by building a coherent picture of a thing and putting it out there. And I'm going to do that with this compiler. The thing that I initially put out there will not be a fully production-ready, build 5 million lines of code video games with it necessarily. I mean, it'll probably work for that, but like it probably won't have a nice debugger and things like that yet. So obviously you need a community to be around it and have opinions on it and invest in building those opinions up and stuff. But I want to put out the initial thing before the opinions start to rain down, because I want people to see what I'm going for and then see what they think about that, rather than having a priori ideas about randomly what a language should be generally. Because if those ideas, they might be perfectly fine ideas, but if they're different enough from this, then maybe they can be applied in a different place. Will I do some kind of language spec document when it's more stable? Yes. It's way too early for specs. What do I think are the most important things when making a compiler? Getting it done and getting it working, and keeping the code simple, because it'll balloon into something really complicated really fast if you let it. And that's why I'm investing a lot of time early in keeping things simple, because complexities breed more complexities, because your later complexities get introduced to deal with the earlier complexities. So if you just hammer the complexities out as early as you can, then you sort of stem this superlinear tide that comes in. Anyway, thank you, folks. Thanks for coming by and watching. Hopefully, somebody got something out of that explanation or looking at the code a little bit. You couldn't see much of the code because Visual Studio doesn't fit very much on the screen anymore. How deep am I going with removing recursion in your code? Doesn't recursion pretty much act like a load of if statements and help keep code smaller? Not really. Recursion doesn't really keep code smaller. It's just sometimes it's convenient, you know. In this case, it was convenient until it wasn't convenient, right? Until it became a major structural problem. So I'm not trying to eliminate recursion from the whole program. There's lots of places where I still do recursion. It's just in type checking and resolution, we can't do recursion in the main line of that. Because that's too involved with external dependencies of the module you're trying to type check. That's the only recursion I'm trying to get rid of. All right, folks, thanks a lot. I will be putting this on YouTube soon if you missed any of it, etc. Goodbye, good night. Have a wonderful evening.